This video demonstrates how we can do an informal hypothesis test using a confidence interval. We can use confidence intervals to perform a quick and dirty, informal type of hypothesis test. Our null hypothesis is always of the form that the parameter, here p, is equal to some null value, p sub 0. Now, if we make a confidence interval and we see that the null value is not included in the interval, remember that a confidence interval can be considered a range of plausible values for the parameter. So this confidence interval would be indicating that the null hypothesis is not plausible based on the sample. And if this is the case, then we should reject the null hypothesis. On the other hand, if the null value, p sub 0, is included in the confidence interval, that would indicate that based on the sample data, it's plausible that the null hypothesis might be true. And in that case, we would fail to reject the null hypothesis. Looking at the example that we used in our hypothesis test for proportion video, where we saw that out of 850 American Facebook users, 60.8% believe that social media companies should be required by law to protect their users from disinformation. We wanted to know, do the data provide convincing evidence that the proportion of all American Facebook users who believe this differs from 50%? And we formulated our hypotheses with a null value, p sub 0, of 0.50. Now, if I make a 95% confidence interval for P, the proportion of all Facebook users in America who believe this, I can use my formula to make our confidence interval, and I find that my confidence interval goes from 0.575 up to 0.65641. So I can be confident, 95% confident, that the true proportion of all American Facebook users who think that social media companies should be required to protect their users from disinformation is between 57.5% and 64.1%. Now, since 50.5% is not included in the confidence interval, it's not plausible based on this confidence interval that the proportion is equal to 0.5 and will reject the null hypothesis. And remember that when we did our formal hypothesis test, we in fact found an extremely tiny p-value, indicating very, very strong evidence against the null hypothesis, and we rejected the null hypothesis and concluded that the proportion of Americans who believe this is more than half. So the conclusion from our informal test with the confidence interval matches the conclusion that we drew from our formal test. So I'll finish up by talking about some of the pros and cons of using this informal method of testing. One of the pros is that it's quick and easy, right? There are fewer steps involved calculation-wise when we are doing a confidence interval than doing a hypothesis test, so that's one pro. Also, you can use this method to do a hypothesis test in a situation where you might be reading information from a journal article that reports a confidence interval but doesn't give you any information about a hypothesis test. You could use this method yourself to perform a test in a quick, easy way. And another pro is that the confidence interval itself gives a range of plausible values for the parameter. So it gives you an idea if you reject the null hypothesis, for instance, how far the truth might be from the null hypothesis. Is this a large departure from the null hypothesis or a small one? So those are good things about using the confidence interval to do the informal test. The con is that without a p-value, you don't have an actual numerical measure of how strong the evidence is in support of the alternative hypothesis. And so that, again, is just one of the reasons that you might choose to do a formal hypothesis test instead of using this informal method. Thanks. Have a good day.